We're going to finish sketching this equation, so I'm going to plug in 1 and got negative 3.6, plug in a 2 for the power, and you get negative 2.25. I'm going to graph those points. That would be off the graph. Negative 1, negative 11, 0, negative 6, there's my y-intercept. 1, negative 3.5, whoops, there we go. And then 2 is at negative 2.25, so it's going to curve down. Now I have to double check where my asymptote is. My asymptote is at negative 1, which means it cannot cross this line at negative 1. So my equation, or my graph, has to curve along that asymptote. And if I were to keep plugging in numbers to my equation, if I were to plug in, let's say, 6, it would approach negative 1, but it wouldn't touch it. Alright, last one is a bonus question. First we graph it. When I graph 2x minus 2, I start at negative 2. The slope is 2 over 1, up 2 over 1. Or you could make a table. My next one would be at positive 3, and it would go up 1 over 3, down 1 over 3, follows the same pattern in both directions. So my solution is this point right here, which is positive 3, positive 4. Now for the full credit, I have to answer, so I have to prove my answer is correct with algebra. So I take 2x minus 2 and say it equals 1/3 x plus 3. I don't want that 1/3, so I'm going to multiply everything by the denominator so that it cancels out. 6x minus 6 equals, that canceled out and leaves 1x, plus 3 times 3 is 9. We are going to then try and get x's on one side, so I'm going to minus x. 5x minus 6 equals 9, add 6. 5x equals 15, divide by 5, and we get x equals 3. Hey look, that matches so far, x is 3. I plug it in to find y. I'm going to plug it into my first equation, this one, because it doesn't have a fraction. 2 times 3 minus 2 is 6 minus 2, which equals 4. Y equals 4. So if I write it as a point, it's x comma y, 3 comma 4. Proof. There we go. Our solution is 3, 4.